Okay, so last day we were looking at simplifying radicals, kind of the beginning part of this. We're going to get a little bit more complicated with this today, but let's just look at a couple of these for review. So let's see here. Let me do 2, and then I'll get you guys to try 2. And then I'll move into simplifying radicals using the division property. So let's look at something like, I don't know, I'll do H and J. Oops, let me get my pen going here. Give me 1 second. Okay, so for something like H, we're taking the square root of AB cubed, or sorry, square root of 25AB cubed. So basically, what the square root sign means is, well, there's a couple things. One, it is just a button on your calculator. So something like the square root of 25 is actually quite easy to do on your calculator. The A and B, we need to do by hand. So it's really important to note that the square root means that this is 25AB cubed to the power of 1/2. That's what a square root means. So J, for example, means that we have negative 16x, sorry, I don't know why I'm writing that again. Sorry, for J, what I mean is we would have negative 16x6yz cubed to the power of 1/3. So the root sign means we're taking a fractional exponent, and a square root is 1/2, a cube root is 1/3. You can imagine for k here, it would be 1/4. So for something like H, it's actually quite simple. The square root of 25 is 5. There's not much we can do with that. There's nothing we can do with the A, but we can remove a B. So the answer to this would be 5B times AB. We can't remove 3 b's, but we can remove a b squared by taking the square root of that. And of course, we can't do anything with the a. So again, this is a review from last day. Let's look at J. Now, the problem with J is I have a negative sign in here. So which doesn't mean anything. You can try this on your calculator if you want. You can try to take the cube root of negative 16. Okay, and this, well, it kind of works, it kind of doesn't work. The cube roots are okay to have a negative in there, but 16, there is no nice number for this. So I need to figure out a number that I can remove from 16 that I can take the cube root of. And an example of that would be, from 16, I know that that's 8 times 3. So I could take the cube root of 8 outside, no problem. Okay, so, and you can do that on your calculator. Second function, the root button.
Mister, where are you answered these questions? Where is these questions?
Page 17 in unit 3.
Okay, thank you.
No problem. So I'm just simplifying this. So x6, y, z, oops, I didn't mean to put the z up there, z cubed. So I can remove the negative 8. That would become a negative 2. The 3 I can't do anything with, so we'll save him. The x, I can take 2 of those, and z, I can take 1. And what we're left with is 3y. And that's it. So anything I can take the cube root of, I can pull outside of this, and anything I can't, oops, I put inside the radicand is what it's called. with my 3. So if you guys want to take a few minutes, maybe you could try I and K, and I'll be back and I'll check your answers. All right, so good luck. Let me know if you have any questions. Oh, and sorry, there's a mistake here. 16 is 8 times 2. This should be a 2. There we go. Not a 3. 8 times 3 is 24. 8 times 2 is 16. Sorry about that. I just fixed number J here. 8 times 2 is 16. All right, I'll be back in a couple minutes. We'll check your answers. Okay, let's look at the answers here. So let's look at number I. Now, number I, we're just taking the square root, which isn't too bad. Oops, that should be a cubed. The problem is we can't take the square root of 18. We need to see if we can remove a perfect square from that first. So I think of the multiples of 18. So like there's 1 and 18. There's, 2 and 9 could be a good one. So if I look at this, 9 times 2, A6, B3. That's pretty straightforward. Sorry, got to put the 1/2 there. So 9 is a perfect square, so I can remove that or take that away from the square root. So that would become a 3. A to the power of 6, that would just be A cubed. We could remove B from this, and then what we would be left with is 2 and 1b. So notice I can remove 2 b's from this, but that will leave 1 left over. Okay, what about letter K? So for letter K, we have 80 W4 Z to the 7. So the 80 is giving me a challenge. So first things, maybe I can try this on my calculator to see if 80 will give me any sort of number here. It probably won't, but it's worth trying. Nope. And I get an answer close to 3, but not quite 3. So I need to think of a number that to the power of 4 would go into 80, and 16 might be an option. Let's see. Yep. So this one's a hard one, by the way, but 80 is 16 times 5. That would be W4 Z to the 7. Okay, so I can take I don't know what to call this. There's a square root, there's a cube root. I don't know what you would call the quarter root, but you can do this on your calculator and it ends up just being, I think I said 2. Let me just double check that. Make sure everything's cool. Yeah, so 2. So 2, I can remove the W's. I'm just dividing it by 4, and I can remove one of the Z terms, but what that leaves me with is the 5, and I still have 3 Z's or Z's, whatever you want to call it. So that is kind of simplifying radicals. We're not done, obviously. We're going to do a little bit more because we're going to look at the division property of these radicals. So division property we already did. Oh, I guess this was in topic 4. We looked at dividing exponential numbers or dividing numbers or variables with exponents. And it's actually pretty straightforward. You just have to remember that when we divide numbers or divide, say, variables with exponents, we subtract those variables. So there's a few examples here. Let's look at A and B and C and then D. Oh man, there's so many. And then maybe I'll get you guys to try some. So example number A would be probably the easiest one, of course. I want to take the square root of A to the power of 7 divided by A to the power of 3. Well, step number 1 would be to simplify what's inside the radical to reduce it. A to the 7 divided by A to the 3. What I'm doing, if you guys can't remember this, is I am subtracting those numbers. So when you have fractions with exponents, if the base is the same, you can subtract those exponents. So A to the power of 4. And then this becomes quite simple. The square root of A to the power of 4, that's just like saying A to the power of 4 to the 1/2. It gets turned into A squared. Again, you can't do that on your calculator. So you're going to need to be comfortable with reducing radicals. So let's look at something a little harder. We have the cube root of 3 and the cube root of 81. But the thing about this, and I guess I can show you this. These guys have a common factor. Now, what do I mean by that? Well, the 3 and the 81 are obviously not related, so I can't subtract any exponents or anything like that. But what I'm actually doing here is I'm taking 3 to the 1/3 and 81 to the 1/3. So because I'm doing the same thing to both numbers, I can actually group them together. So that's where this comes from. This root 3 to, under the radical sign 3 over 81 comes from this property. Because the expression, or because the radicands have a common factor, we can write it as a single radical. This is a division property of radicals. So now I can use my good old trusty calculator, and actually you could do this whole thing on your calculator if you wanted. If you ever see a question with just numbers, you can just put it in on your calculator. But anyways, I'm going to reduce the fraction 3 over 81. 3 over 81 reduces to 1 over 27. And then I'm going to take the cube root of both numbers. Again, you would do this on your calculator if you didn't know. The cube root of 27 is 3. So you can try, again, you can try all of this, anything with a number, not a variable, you can do this on your calculator. The cube root of 1 is just 1. So that's where the 1 over 3 comes from, if anybody's wondering. Okay, let's look at a harder one. Okay. Well, actually, this one's not too bad. So I have 7 root 50 over 15, and I want to simplify the root 50. Okay, not too bad. Basically, I'm going to simplify everything and reduce any fractions. So I want to simplify root 50 is my first goal, square root of 50. Now, again, anything with a number in it, you can do this on your calculator. So the square root of 50 becomes 5 root 2. Okay, this is the workings for it up above, but it becomes 5 root 2. How did root 50 become 5 root 2? Well, root 50 can be simplified as 25 times 2, and the square root of 25 is 5.
Mr. In numbers, I don't have to write details, right? Just put it in the calculator and it will be.
Yep. You don't have to
give me the results.
Yep, exactly. So yeah, you don't have to write anything. If you just have numbers, you can just put the answer there. You don't have to show any workings. But I wanted to show people where this 5 root 2 came from, just in case you weren't sure. Okay, so now what do you do? Well, I am, I guess I'll leave that there. I'm here. I haven't gotten rid of anything. I've just simplified I simplified root 50. So I still have my 7 and my 5 and my 15, but I'm going to reduce to lowest terms. Again, your calculator can do this for you, but my final answer is 7 root 2 over 3. And I'm pretty sure if you did put this whole thing in your calculator, so if I went 7 times square root of 50, and divided it by 15, making sure I'm careful with my brackets. Yeah, my calculator would say 7 root 2 over 3. So you can do the whole of question C. You can just skip and just do right on your calculator if you want. The problem with using your calculator, though, is it will not help you with something like D. So let's have a look at D. Excuse me. And then maybe I'll do 1 or 2 and get you guys to practice a couple. And then we'll move on. This is topic 21, and your test includes up to topic 24. So today I should get through topic 22, and then tomorrow we can do 23 and 24. So that'll kind of bring you up to date for your test. But anyways, let's look at D. The radicand. Okay, so first question D. It's a quarter root, I guess you would call it, or a square root with a 4 there. So the radicand here under it has numbers and letters. So little bit of work to solve this one. We want to simplify this as much as possible. So what I do is in the fraction, first thing I do is reduce this. So I could reduce the 2 over 32, and I could reduce the C's. So 2 over 32 gives me the 1 over 16 here. C5 divided by C, right? C5 divided by C is C4. That's where the 4 comes from. And then there's not much we can do with the D. There's no, we can't reduce it inside the radical. So once I've reduced the factors, the factors in the fraction, then I apply the division property of radicals and simplify. So I take the, the root, the quarter root of c to the 4, which is just 1c. I do the same for 16. And again, you can try this one on your calculator if you don't believe me. This would be 2. And D would be nice and easy. It's just 8 divided by 2. Sorry, 8 divided by 4, which is 2. So let's do a couple of these, and then I'll get you guys to practice.
Sir?
Yes?
The test will not be till 26.
Nope, it's till 24.
Because in tutorial you wrote 26.
Oh, that it should say 24.
You said from 15 to 26 in the
Yeah, it should say 24.
Okay, thank you.
Cool. Okay, so let's look at these. A is pretty easy. So A, it would be x cubed over x. So that would be x squared. And then I take the square root of that for just x. Pretty straightforward. What about something like, B? Okay, so B, again, pretty straightforward. Oh, actually, I'm giving you guys the, maybe I'll do some of the harder ones. So let me, excuse me, let me try a harder one. B, what you would do is first you would subtract the exponents, so 21 minus 5, which would give you a 16. That would be V8. Oops. So that one's pretty easy. Let me do a harder one. Okay, something like E. E, you can do the whole thing in your calculator. So what I'm going to do on my there's a few ways I can do this on my calculator, but a way to simplify this is it's basically 64 over 2 to the power of 1/5. So 64 divided by 2 is 32. And then I can do the rest on my calculator. And I get 2. Again, you could do this whole thing on your calculator. What's another one? Okay, let me do one with letters in it, and then I'll get you guys to maybe practice a couple others. But these are pretty straightforward examples here. So let's look at J. Okay, so for J, I mean, the first thing I'm going to do is reduce the fractions in here. I'm not going to do anything yet. Okay, but I am just going to make a note that this is a cube root. Now, the first thing I want to do is reduce the 54 over 2. 54 divided by 2 is 27. Now, what else do we have? X17 over x to the 2, so that's x15. And here what you would actually get is this would be over y18. So now I can do the properties of radicals. I can take the cube root of the top one, and I can take the cube root of the bottom one. So what I end up getting is 3 x5 y 18 divided by 3 is 6. And there we go, reduced. All right. So why don't you guys try a couple? Yeah, maybe you could do, I'll give you guys some of the harder ones. Why don't you guys try like G and H and I? And if you want to, you can try K. And I'll be back in a few minutes with the answers.
54. How we make it 27? Mr.
Okay, so let's look at
Mr.
Yes.
Mr. I want to ask you, as square root of 3 of x15 power 15, how it will be 5?
Where did you see that?
in J, yes, here, in J.
It's not square root, it's cube root.
Cube root,
Yes.
how it would be 5, the
So
X.
x to the 15 to the power of 1/3, that's x to the 5. 15 divided by 3 is 5.
Okay, thank you.
No problem. Okay, so let's look at the answers here. Okay, so for this one, it would be root 300 over 15 is not the answer, is the first thing. And then you could put root 300 in on your calculator. So I get 10 root 3 over 15. And then I reduce the 10. So this would be 2 root 3 over 5. All right, again, you can do this whole thing in on your calculator. So not much I can do with this one first. 5 root 3, 16 over 6. I guess I just rewrote the same thing, sorry. So what I'm gonna do is simplify the cube root of 3. Again, you can put that, the cube root of 16. Again, you can put that in on your calculator. Or maybe you can, maybe not. If not, I'll show you how to do it. Give me 1 second here. Aha, okay. So for 16, my calculator, when I try this, is giving me a decimal. So what I'm going to do for the 16, I'm going to rewrite it with a cube root in it. 8 is a very popular one. I know that 8 times 2, I can actually take the cube root of that. So what I end up getting is 5 times 2, the cube root of 2 over 6. And then I'll reduce my fraction. So this would be 5 cube root 2 over 6.
Mister,
Over, not 6, 3. Yes.
Mr. 3.
Yeah.
The
the
base is
answer of
3.
G
Yeah.
is 2 root 3 over 3, not 5.
Well, let me just check. So that's good over 6. No, I think this is okay. This should be a 3 on the bottom when I reduce the 2 and the 6.
No, I mean question G.
Question G, 3 square root 3, 2 square root 3,
Oh.
the bottom are 3.
Yeah, 3. Thank you for that. Perfect. Thank you. All right. So what about I? Excuse me. I got like something in my throat today. What are we going to do about
Mr. on H, I wrote it as a decimal. I wrote 2.9.
if you get
99.
decimals, you will lose marks.
Why?
You need to reduce radicals as radicals. You cannot write decimals for these.
Okay.
So for I, we get 5, 372. Okay, I guess I'm writing that again. I don't need to do that. So what I need to do is simplify the 72. So I need to come up with a number that goes into 72. Like, for example, what would be a good perfect square that goes into 72? I know 8 and 9 would go into 72. So let's try that. 5, I could rewrite this as 8 times 9 to the 1/3 over 12. And then I can remove this. So I get 5 times 2. And then I still get my 9 in there over 12. And then I'm going to reduce by 2. So I get 5, 3 root 9 over 6. And there we go. There's that one. All right, so let's look at topic number 22. Topic 22, adding and subtracting radicals. So this says, yeah, we're going to do exactly what it sounds like, adding and subtracting radicals. Pretty easy concept, except you need to make sure that when you add the radicals, they have what's called a like radicand. And what that means is it's kind of like adding fractions. You know, when you're adding fractions, they must have a common denominator. Well, these must have a like radicand. So two radical terms are said to be like radicals if they have the same index and the same radicand. Now, what does that mean? All that means is the square root part, or the root part, the radicand part, must be the same. So it needs to have the same index, as in, you know, if it's cube root, or, you know, 4, it needs to have the same number there. And what's under the number needs to be exactly the same as well. So these are some pairs of like radicals. We have, let me get rid of my writing here, negative 7a root 5 and 3a root 5. Here, these look pretty complicated, but again, it still has the cube root 15b, cube root 15b. These are what we would call like radicals. It's kind of like adding fractions, you know, like fractions. These pairs of terms are not like radicals. So root 6 and then this 4 root 6, it's not the same. Yes, the numbers under the root sign are the same, but the 4 is not the same. One is a square root and one is, you know, a 4 root, whatever they call that. Not a cube root, not a square root, a 4 root. Same thing here. These are both square roots, but one is root 3 and one is root 10. So not the same numbers. So very easy, quick warm up here. Determine if the radical terms are like, just answer yes or no. So this is pretty easy. So like just to warm up here, the answer to A is no, because this is a square root and this is a cube root. The answer to B would be yes. There is a 3, but that doesn't matter. It's still a square root 2 and a square root 2. So why don't, and you don't have to go down into this section, but why don't you just try this practice one and answer yes or no if they have like radical terms. All right, and I'll be back in a minute. All right. So any not many questions in the chat here, so it's or not many answers in the chat. So let's look at these. Excuse me. So C, root 2 and root 5, are they the same? The answer is no. 7 cube root x and cube root x. Of course, yeah, they're the same. These 3 root x, 4 root x, that's a no. And here, no, not even close to being the same here, because this is the square root of x and this is 2. So no. Now, knowing this is the first part of answering these questions. To add or subtract like radicals, we are going to then use our distributive, I can never say that word right, distributive property. So again, I'll do some of these with you, but if I was adding 2 root 5 plus 6 root 5, think of that like 2x plus 6x. I know root 5 is not like x, but we follow the same property. If I had 2 root 5 and 6 root 5, it's similar to saying I have 2 x's and 6 x's. So I add them together to get 8. Subtracting, very simple. 9 minus 4 is 5. The only thing I need to make sure, like if this was x's and y's, if I said 9x minus 4y, right? Sorry, I don't know why I wrote the answer there. You can't do the answer to that because x's and y's are not the same. But if this root or radical sign is exactly the same, so it has the same index, which is the number, and it has the same radicand, which is the number under the root sign, you can just subtract them. It's like saying 9x minus 4x. So it's actually pretty easy. Excuse me. So here we're going to add or subtract as indicated. 6 root, I guess, sorry, I'll do it down here. 6 root 11 plus 2 root 11. Well, 6 plus 2 is 8. I have 8 root 11s. Pretty straightforward. What about root 3 plus root 3? Well, that's like saying x plus x. I'm going to have 2 of them. So now one thing you'll notice is there's actually ones in front of these. Like, if I said x plus x, you guys would say 2x. So root 3 plus a root 3. Don't say 9, don't say 3, don't get confused. Just put them together. It would be 2 root 3. I wonder if your calculator does that actually. Maybe. Your calculators are pretty good. Typically, anytime there's numbers, yeah, your calculator does do that as well. All right, and it just says here, for avoiding mistakes, just be careful. Because if the root sign is not exactly the same, you cannot add them together. All right, so let's look at C. What was C? Let me scroll up for a second. Okay. I just wanted to make sure C was written. I didn't, the pink part confused me there. So it's -2, and then it's the cube root of AB. Then we add 7, then it's the cube root of AB, and then we subtract a 1. So we put together the numbers, -2 plus 7 minus 1, and we get our answer. This is pretty straightforward. Now, what do you do with D? In D, you have fractions, okay, which doesn't really change anything. Just be careful, and you can still do these on your calculator. I have 1/4, and I'm going to subtract from that 3/2. So you can just do this straight on your calculator. 1/4 minus 3/2 would give us, and again, calculator straight away would say -5/4. The only problem with this one is you can't enter anything. Well, I guess the only problem with any of these is, you can't put the variables in on your calculator, but still, it's pretty straightforward. So the only way that this gets harder is, well, sometimes we might need to simplify these before adding them or subtracting them. And that's kind of like when you simplify fractions. So let me give you an example. Like if you had, I'll go simple on this, 1 over 2 plus, like, I don't know, 2 over 4, you would simplify this fraction first. So this would be 1 over 2 plus 1 over 2. With radicals, we might need to simplify them first before we add them. So if you look at A, B, and C, it might not look like these can be added together, but they actually can. We can add these together if we reduce these radicals, or if we write them in the simplest form. So looking at number A, you might think there's no way I can add 3 root 8 plus 2. And it looks like I can't, but root 8 can be simplified as 2 root 2. Now, where did that come from? Well, you can take the square root of 8 and you can write it as 4 times 2. That's where that 2 comes from. 2 times 2. So the square root of 8 is 2 times 2. So this becomes 3 times 2 root 2. And then that's 6 root 2. And then I add them all together. So 6 root 2 plus 1 root 2 would be 7. Not too bad. For something, I'll go a little quick through B and C because then I can do some with you. B is very quick because the thing with B is I'm going to remove the y2 from this, meaning, actually, I'm going to remove 2 things from this. I'm going to remove the y. The square root of y squared is just y. But where did this other x come from? Let me zoom in here. The square root of x cubed times y squared is xy times x. I can remove an x squared and a y squared. Now, once I've simplified that, I have the same radicand and the same index. It's all good. So I can subtract this like normal. 8 minus 3, right, is 5, and that's it. All right, I'll very quickly do C, and then we'll do some together down here.
Mr. Mark,
Yes.
the answer should have always the same radicands, or
Yes.
it could be different.
No, it cannot be different.
Can I put it
Also,
in x power 3, not x, just x?
Nope, that would be wrong.
Also in front of the square root, the answer should be the same, or can be like different numbers, but with the same variables.
So like these don't have to be the same. No.
But the variables should be the same. Yeah? I mean,
yeah.
Whatever variables you have to work with. Yeah.
Yes.
Okay.
Yep.
No problem.
It's just like we did in topic, I don't know, 4 or 5, you know, you can't add together 6x squared plus 7x. They can't be added together. The variables have to be the same. So we've done this a long time ago. Topic, I don't know, 6, 7, or 8. The variables must be the same, or they cannot be added together. So question number C, excuse me. Question C, obviously a challenging one. You know, nothing here looks to be the same, but what happens is we can simplify all of these root signs to be xy squared root 2y. Every one of these can be simplified to be xy squared root 2y. And as the student just, I think it was Nasser, you know, these have to be exactly the same. The numbers don't matter, but the variables, the x's, the y's, the roots, they all must be the same. So 5 minus 13 plus 7 5 minus 13 plus 7 is, what's that going to give us? A negative 1. So if you're wondering where the number went down there, 5 minus 13 plus 7 is a negative 1. Okay, so let's have a look at this. Let's look at some of these together. How many of these are there? Okay, there's a good few for practice here. So we'll do, I'll start with some easy ones and then we'll do a couple harder ones. So let's start easy. A says add or subtract the radical expressions as indicated. A isn't really a fair one because the square root of 36 is 6 and the square root of 81 is 9. So there you go. That's 15. That's easy. Questions like B, C, and D, you guys can actually do on your calculators, but I'll show you how to do it without a calculator. So let's look at like something like number C or letter C. Yes?
This question will be in details, like you want the step in the test.
It's up to you.
Okay, it's up to me, but I think in the if you want the step and I give you only the answer, I will lose.
No, if you give me only the answer and it's wrong, you get 0. If you give me only the answer and it's right, you'll get marks.
Even if I didn't write the steps.
Yes.
Okay.
All right.
Thank you.
No problem. So question C here. Now, I got a problem with C. None of these root or radical signs are the same. So I need to make sure they're the same, so I can get these put together. So what I end up figuring out, or what I can figure out, is I can simplify root 63 and root 28. All right, so
You can put it on the calculator as well.
Yes, exactly. So 63, and again, this kind of, you need to know your multiplication skills, is 7 times 9. Okay. And what about 28? Okay, well, the negative 2 stays. 28, well, 28 will be 7 times 4. Okay, so this square root of 9 and square root of 4 I can remove. So I would get 4 root 7 plus 3 root 7 minus 2 times 2 root 7. So again, I don't need to do all of these steps here, but I will. So 4 root 7 plus 3 root 7 minus 4 root 7, and we get the answer 3 root 7. All right, cool. And again, something like C you can do on your calculators. Okay, well, why don't you guys take a minute or two and try these? So you should try D and you can try E, and then I'll be back to check your answers in a minute. So why don't you try D and E, and then I will be back to check your answers. All right, let's have a little look at the answers here. So for something like D, again, the problem with D is we have root 27, root 75. They're not going to be easy to solve. So what I need to do is I need to reduce these, reduce or simplify these radicals. So 8 root 3 minus 2. Now, root 27, that's the same as 9 times 3. Or I'll do it like I did the last question, 3 times 9. What about root 75? Well, that would be 3 times 25. So now, because I have a perfect square here, it's easy to solve. 8 root 3 minus 2 times 3 root 3 plus 5 root 3. And then I just solve. So 8 minus 6 plus 5. 8 minus 6 is a 2. 2 plus 5, I get 7 root 3. All right, did anybody get something different? I hear somebody's microphone.
I got 9 root 3.
You got, sorry?
I got 9 square root 3. Because I put like the 2 square root 3 times 9, it give me 4 square root 4. 4 square root 3.
Okay, let me just check something.
I have the same answer.
As me?
Yeah.
Yeah, I think you made a mistake.
Yeah, even I got 7 root 3.
Yeah, it should be 7 root 3.
Yeah.
All right, let's look at E. Now, again, E, you could just easily do E on your calculator. No problem. So if you have a nice Casio calculator, please bring one on Tuesday. You're going to need one on Tuesday. But you could easily just put this in on your calculator. Well, maybe not, because mine actually gives me a decimal. So I'm going to need to do some work here to figure out how to get these the same.
Yeah, mine gave me a decimal too. I was confused. I don't know what to do.
Okay, well, I've been showing you what to do for the last hour, so let's practice.
Yeah.
Let's see what we can do here. Now, it's the same as putting it to the power of 1/3. So I need to figure out a perfect cube that goes into 81. You need to think of the multiples of 81. So let's see here, try some numbers. 9 isn't going to work because you can't take the cube root of 9. Well, let's try some other numbers. 8's not going to work. Let's try 16. 16 doesn't work. Let me see.
Sir, we
9
can take
multiply
the
9.
root of 9.
Sorry?
Root of 9 is 3.
Roots of 9.
Yes, but guys,
9
this is
root with
cube root, guys. This is cube root.
Oh.
3 cubed times 3.
2 over 3.
1 second, guys.
3 cubed times 3. It will show
Yeah.
answer.
So what this ends, it just took me a while, try some numbers on my calculator. 81 is the same as 27 times 3. And the cube root of 27 is 3. 3 times 3 times 3 is 27. So that's good. Okay, so what about 24? What can we take out of that? Let's see, probably 8.
Cube times 3.
8, yeah, 8 times 3 is 24. Okay, so 27 and 8 are perfect cubes. The cube root of 27 is 3. So I get 3 cube root of 3 minus 2 cube root 3. And then I can easily subtract. 3 minus 2 is 1. So my answer is 1 cube root 3. You don't need the 1 there. You could just say 3 root 3. guys, just earlier, people were saying to use 9. Remember, this is a cube root, so I can't use 9. I need to think of cubes. All right, we're almost done. Let's do a harder one. I'll pick one with some variables, and then I'll just introduce topic 23, and that'll be it for today. So let me do a harder one. Let's try something like I, and then I'll introduce topic 23, and then that's it. So I, 5p times the root of 20p squared plus p squared root 80. Well, the challenge here is I definitely need to get what's under that root sign equal. So 5p root, how can I simplify this? Well, 20 can be written as 4 times 5. And of course, I can take the square root of p squared. I'll just leave that in there for now. And what about 80? What are some number? Well, 8 times 10.
4 and 5.
4 and
4.
4 times, like 16 times 5, you mean?
Yeah.
Yeah, 16 times 5 is 80. That's good. So what this ends up being is I get 5p. Now I'm not done. I'm going to pull the p squared out as well. The square root of p squared is another p. The square root of 4 is 2. And then I put the root 5 in here. And then I'm going to get plus p squared root 5. Okay, now this is starting to look good. I'm going to simplify the left-hand side. So I'll get 10p squared root 5 plus p squared root 5. And that's it. Oh, hold on, I might have missed a number. I missed a number up above. Sorry. I forgot to take my 4 out. Everything was good. I just left out this 4. So don't forget the 4 there. 16 squared is, or sorry, the square root of 16 is 4. There we go. So 10p squared root 5 plus 4p squared root 5 would give me 14p squared root 5. And that's it. All right. Now, I'm going to finish here in a couple minutes. I'm just going to introduce the next topic so we can get started with it tomorrow. The next topic and kind of the last part about radicals here is we're going to look at multiplying them, which I won't go too far into this today, but we will tomorrow look at multiplying radicals. To multiply two radicals, it's actually pretty simple. Let A and B here represent real numbers. And when I multiply two radicals, I can just multiply the numbers under that radical sign. It's not very challenging. And again, most of it you can just do on your calculator. The only thing, guys, is for simple radicals like these, and we won't get into the hard stuff today. We'll do that tomorrow. I shouldn't say hard stuff, but notice here that the indexes are the same. If the indexes are not the same, there's a little bit more work to be done. Okay, and we won't talk about that today. That'll be another topic for tomorrow. But if you look at this example, like example number A, 3 root 2 times 5 root 6. Well, 3 times 5 is 15. Root 2 times root 6. 2 times 6 is 12. And then you just simplify. So you multiply what's outside of the radicals and you multiply what's inside. For a question like B, 2x times a negative 7, well, that would be, let me scroll down, 2x times negative 7 is negative 14x. So do what's outside. And then I'm going to multiply what's inside. Y times x times y is xy squared. And I keep the root sign. Then simplify. So I think I'll leave it here for today. That's enough information for you guys today. But you know, tomorrow we'll kind of continue and look at multiplying these things. There's one special one, wink, 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 tomorrow that I'm going to show you, question number B, but we'll save that one for tomorrow.
So tomorrow we're gonna reach the last topic, yeah? It's
Yes.
24.
Yeah, tomorrow. We'll,
Then khalas, nothing else.
well, I mean, we still have like a week and a half left of school.
Oh, okay. So after it, we're gonna start again, or?
No, well, we're going to finish chapter 3 and 4.
Oh, okay. So we still have like 2 chapters, yeah?
Yeah, well, this is chapter 3. We still have to finish chapter 3, which we'll do after the test.
No, I mean, test number 2 is gonna be at Tuesday, yeah?
Yes.
Okay, so after it, we're gonna finish like the what left of chapter 3, and then we're
And chapter
just gonna
4.
head on chapter 4 and
Yeah, we keep
that's the
going.
final.
Yeah, we're not done.
Okay.
We have school until June 16th.
So June 16 we finish?
Yes, then you have exams.
Okay. No problem.
All
Thank
right. Bye, guys. I'll see you tomorrow. Take care.
See you.